Okay, so this time we got some geometry going on here with, again, we're going to do, looks like we're going to be doing an enlargement of this particular triangle ABC from point D, which is in the center here, and we're going to make it 150% bigger. Okay, so that means is that our scale factor is going to be 1.5. So that is our scale factor. Okay, and so what we're going to do in order to build this thing is that I'm going to list all the points A, B, and C below. Okay, so basically I just listed these points down below, and to do something that is going to have a scale factor enlargement of 1.5 or anything that is going to be dilate from the origin is going to go ahead and be pretty simple to do. Okay, so for example, A prime, if I wanted to do out A prime, I would take the scale factor, which is 1.5, and I would multiply that into these guys right here, and that is going to give me, it looks like negative 6 times 1.5 is going to give me a new point of a negative 9, and 1 times 1.5 is going to be 1.5. Okay, so what I'm going to do is that I'm going to complete that multiplication process for each one of those, and you can kind of imagine it as the distributive property that you're multiplying each one. Technically it's not the distributive property, but if it helps you remember, then you can think of it like that. So finding B prime and C prime would look like this. Okay, and so we have the points for A, B, and C prime, and so what we want to do is that we want to put them on the graph then, and so I'm going to put them in a different color. So let's go A prime, which is going to be a negative 9, 1.5, which would be about right here. So that will be A prime. B prime is going to be a negative 9, negative 3, which is going to be about right here. And then finally C is going to be 4.5 and a negative 3, so down here. Okay, so what we want to do is connect all these points up and see where this takes us. Okay, and so there is our new triangle, A prime, B prime, C prime. Okay, and it has been enlarged a scale factor of 1.5. And so we can go ahead and show that each one of these points are going to be collinear, the A and the A prime, and the point dilation B and B prime, and point dilation and same as C. So let's take a look at that. Okay, so that collinear attribute is it holds up. Okay, so that looks pretty good. And what we're going to do is that we're going to investigate a little bit further with the next example, and keep in mind all the properties of these dilations, and see how this is going to play out when we really start to put all the pieces together. So meet you in the next video.